Okay, good morning. Uh, Today we will continue the factors, chapter 12. I think we can continue until 12.5 for today and maybe finishing the factors on Wednesday on 12.6. And maybe on Wednesday also we can have some exercise for chapter 10 or 11, but it depends on our progress. If we are sufficient in our time, if we have time, we can uh, try some exercise. But for now, we can focus on 12.4 and 12.5 for today. Okay. Uh, Last discussion, we have this theorem. I haven't explained and why we are having these terms now. Okay, so if you have A cross B, so the length, this is means the magnitude or length. Okay. If you remember, if you have, let me write here. If you have length of A, if A is a vector, let's say A is a vector of A1, A2, A3. Let's say we have this. And the length will be A1 squared plus A2 squared plus A3 squared, right? Okay. Now, to explain this, to explain why we have this sign, we can try to make the same length formula. But now we have the cross. Okay. So we are using the cross. I have right here. We have the cross here. Cross here. And let's write all these terms in here. Okay. So this should be in the square root. It is. I think it's quite long, so I need to make longer. Okay. So first is A2 B3 minus. Let me write like this. A1, A3. Let me check. Yeah, 2 3 1 3 1 2. Okay. And then squared, and then plus A3B1 minus A1B3 squared. Need longer here. And plus A1 B2 minus A2 B1 squared. Okay. Now we have this long square root terms of cross product of the length. And the next thing, to remove the square root, we can square. Okay, so square this A cross B and square all this. So let's expand the results. So this becomes squared. Now the inside here, all the brackets, let's just expand this. Okay, so squared minus 2, multiply this, and then squared. So let's expand the formula. And let's see how we can move on and make a pattern. So this become A2 squared BT squared minus 2a2 b3, or to make it more order, maybe a2 a3 b2 b3. Okay, so a b b, and then plus a3 squared b2 squared. Let's move a little bit left and move a little bit to the left. And that's same thing, expand this. So a3 squared, b1 squared minus 3. And then minus 2 a1, a3, b1, b3. And then plus a1 squared, b3 squared, b3 squared. Okay. I think I need to move a little bit to the left. Now plus a1 squared b2 squared minus 2a1 a2 b1 b2. Let me move this to here. Okay. So plus a2 squared b1 squared. Okay. Okay, now we have a long terms of expansions. Now this is quite a little bit tricky, but what we are going to do is we will have we are grouping a1 squared plus a2 squared plus a3 squared, and then grouping also b1 squared plus b2 squared plus b3 squared. So if you multiply all of this, you will have the same this, right? So we need to add, or in this case, we need to subtract a1 b1 plus a2 b2 plus a3 b3 and the square. Oh wait, this one. Okay. Okay. Now this part, this a, this part is the same as this, right? So if you squared, it's squared if you have all this, right? So this is actually the length of a squared, and b, you have length of b squared here, and then this, all of this are a dot b, right? And then squared. a1 b1 plus a2 b2 plus a3 b3. So this become minus a dot b and then squared. Okay, now we can write this, the a dot b we can write as the terms. So we can exchange this length A, length B cos theta for A dot B. So let's change that. So minus, and then cos squared theta. Now let me move here. So A cross B squared is A squared B squared minus A squared B squared, and the cosine becomes 1 minus sine squared. Or let me just make this into factorize the A squared B squared 1 minus cos squared theta. Okay, this much simple. So we have this become sine squared, and we can square root both of this equation, and we have these terms. So sine squared theta is sine theta because sine theta is positive when the theta is between 0 and pi. Okay, that's the formula for A cross B. The length of A cross B we can relate to the sine theta, the angle of sine, okay? The angle between A and B. Okay, any questions? Any questions? The trick for expand this formula is, I think, from this section going forward to this, it takes some algebra to make out of this equations. Okay. So you need to think how we can make this calculation here correctly, and we can take out some of element from it and factorize into this equations here. Now let's move on to some. We still have something in cross product. Let's go to the next page. So two non-zero vectors A and B. We can say that both are parallel if and only if A cross B is 0. So this means 0 means theta is 0 or theta is pi. So in terms of length, this will be 0. So let's say this is A and this is B and this is our angle theta. So if this is 90 degree, this is B sine theta. And actually, if we are using the parallelogram here, so the area of the parallelogram here is actually our length of A multiplied by the height, the B sine theta. And actually, this is our definition of A cross B. So cross product, you can imagine like a two triangle in terms of A and B. And if you combine this two triangle, it's become the parallelogram. If you observe the area, it's become the cross product. So length of A cross B is equal to the area of parallelogram. So if you need to find any area or triangle or parallelogram, you can relate to the cross product. Okay? If you have the coordinates, you can find the area and use the cross product formula. And now orientation based on the standard basis vector. So let's say we have I, j, and k for standard basis vectors. And using, let's say the theta is pi over 2. Let's say we have I cross j is equal. So let me write besides this. Let's say this is I, j, and k. Okay, based on uh, the picture, let's use our hand to determine. So I cross j. So using your hand crossing to j. So if you see here from this side, it's going up. Okay, you get the idea. Okay, it's like when you learn physics, the factors in physics. Okay, so this will be k. Okay, and then j cross k. So from j cross k, it's going here, right? Okay, it's I. So it's going I, and then k cross I. So k cross I. So it's going here. Okay, it's j. Let me write j cross I, k cross j, and I cross k. So j cross I. So j is here. So before we have I cross j and it's k, but now we have from the reverse. Okay, so if you rotate the picture and you imagine you rotate j to I, it's going down. Okay, you need to to imagine. Okay, to visualize the movement. So this become minus k, and k cross j. So k cross j. So it's from here going here. So it's going to the negative I, right? Okay. So it's negative I. And then I cross k from here, and then going to k, and then the direction of your thumbs will be your minus j. Okay, minus j. Okay, and we can see from here that if you see the relations, the I cross j is not the same as j cross I. Okay, one is positive and the other is negative. Different orientations, right? Different direction. For example, if you check I cross j, this will be I cross k, which is negative j. But if you're trying different bracket here, I cross I is 0, and cross j is becoming 0. So it's not commutative. So this cross product is not commutative. So not commutative. So different from the dot product, which you can easily calculate. For cross product, you need to be careful because it has certain orientations that you need to take care. Okay. So this is not the same as A cross B cross C. But some of the property, they are similar to the algebra, the common algebra. So let's say properties of cross product. So if A, B, C is a factors, non-zero factors, of course, and D is scalar, so A cross B, this is the same as minus B cross A. And if we have scalar and then vector and then cross, this is the same as, you can factorize the scalar and then A cross B. Or you can exchange the scalar and write into, okay. The next one is A cross. If you plus the vectors, then you can have A cross B plus A cross C. So it's similar to some algebra rules. This is also similar. And if you dot the cross, you can also exchange and make it and replace the factors. Now the interesting part is the last one here. You can make it into A dot C and then B minus A dot B and then C. This number 5 here is called the triple product. I will explain this. Let's move here. So let's say you have 3 vectors. They have three vectors. And then let me write here. A dot B cross C. Now we can write B cross C and then multiply with the A1, A2, A3. So A1 multiply with the cross is B2, C3 minus B3, C2. And plus B3, C1 minus B1, C3. And plus B1, C2 minus B2, C1. Now let's just multiply all A1, A2, A3 into the brackets. So let me write using different color. So A1, B2, C3 minus A1, B3, C2. And plus A2, B3, C1 minus A2, B1, C3 plus A3, B1, C2 minus A3, B2, C1. And then grouping based on C. Okay, so let's start from C1. C1 is A2, B3 minus A3, B2. And C2 is A3, B1 minus A1, B3. And C3 is A1, B2 minus A2, B1. And we can conclude that from this expansions that A dot B cross C is A cross B dot C. Okay. To prove that that is correct. Okay. Okay, now the same as this triple product, okay, this scalar triple product. Okay, let's say this is B, this is A, this is C. and this is B cross C. And it's become this height. And if you see we extend this into three dimension. This becomes, if the two dimension, the base is parallelogram. If this becomes the three dimension, it's called the parallel pipe. And the base, okay, the base is parallelogram, which we have discussed before. We can find the area through the cross product, right? So the area is B cross C. And if we have angle between A and B cross C here, so let me write here. So theta is angle between A and B cross C. Then the height becomes A cos theta. So therefore, the volume of this parallel pipe is area multiplied by H. So area is B cross C, and height is A, length of A, and then length of cos theta. Notice that I'm using the absolute value for cosine because in case theta is greater than pi over 2. And we can simplify this, become A dot B cross C. So so volume of parallel pipe determined by vectors A, B, and C is the magnitude of scalar triple product. Okay, and actually that's it for all the cross product. Okay, one application for cross product is, I think in physics you learn about the torque, okay? The torsion. The torsion is based on calculation of cross product. Okay? The the torque is the radius cross the force, right? So if we have, this is the radius, and you have force going on here, your torque will be going here. So we see R cross F. So going there. Okay, that's 12.4. Okay, now we can move on to 12.5. Let me move to the next page. Any question from cross product? Okay, let's check the 12.5. This is equations of lines and planes. Let's start with the drawing the three-dimension space. Okay, let's say uh, we have the vector here. Let's say this is v, and then this is r0, and this is r. And we have 2 points, P, and this will be P0. Let's say this is line, and from P0 and P, from this point to this point, we have A. Let's say A. Okay, that's A. So R0 and R is position factors for P0 and P. So R0 is actually OP0 and R is OP. And A becomes P0P vectors. Now, from this figure, the triangle law of the vectors giving the relations between R0 and A. And then the A is actually parallel with P. I think, yeah, it's parallel with P. So there is a scalar, let's say T, such that A will be equal to some scalar T and then vector V. And we can write this as which is the vector equation of L. And the T then becomes the parameter, okay? Like in the parametric equations. So this will be also the parameter. So every time you are changing your T, you are changing the positions of the vector. So the parameter T gives the position vector of R. So if you are looking at this vectors A here, as the T changes, okay, as the T changes, so from R here, so if, for example, you start from T is maybe less than 0, maybe the R will be from here, and then it's moving up until here, okay? So we can also think the vectors in terms of parametric. So we can imagine the vectors is changing. So the vectors is R, that is our equation. So maybe this is the R0, but we can also think that if this is negative, we can have from here maybe, and maybe change here and maybe here. Okay, I hope you get the idea of we include the T as a parameter to change the positions of the vectors R. Okay. And now the equation R, we can write also in terms of each axis x, y, z. Let's just write R x, y, z, and then R0 is x0, and let's plus the parametric, the t and v. Let me write here. Let the v is equal ABC, and R is XYZ, R0 is X0, Y0, and Z0. And this becomes a plus TA, and then Y0 plus TB. And then Z0 plus TC. Now we have the scalar equations of each axis. We can write the h of x, y, and z. So this becomes our parametric equations for a line through point, let's say the point x0, y0, and z0, the initial point, and parallel to a vector v, which is the vector v is a, b, c. Okay. But let me give you an example, and then we can conclude another relations from this parametric equations. So let's write the example 1. Find vector equation and parametric equation for the line that pass through point 513 and parallel to vector I plus 4j minus 2k. And find also two other points. So you need to find the vector equations. Vector equations means you need to find the R, okay? And parametric equation, you need to find the x, y, and z. Okay. Now, from the information, we know that this line needs to pass through 5, 1, and 3. So 5, 1, and 3, that is our initial, right? Initial point. Or we can say that the R0 is our vectors 5, 1, 3. Or we can write this as 5i plus j plus 3k. And v is I plus 4j minus 2k. So the vector equation are, this should be from, let's write 5i plus j plus 3k. This should be plus vt. So let's write t and then I plus 4j minus 2k. And let's make into simplified for ijk. So 5 plus t I, and then 1 plus 4t j plus 3 minus 2t k. So this is our vector equation. Now the parametric equations will be x is equal 5 plus t, y is equal 1 plus 4t, and z is 3 minus 2t. Okay, this becomes the parametric. And this becomes the vector equation. And how to find the two other points? We can just use any t that we want. For example, choose t equal 1, and it will give the x equal 6, y equal 5, and z equal 1. So 6, 5, 1 is a point in the line. And similarly, if we choose -1, x is 4, y is -3, and z is 5. So 4, -3, and 5 will be also the point on the line. So the vector and the parametric equations of the line is not really unique. Okay. So if we change the point, all the also will be changing. All other points will be also changed. Okay. So from here, if we see the v here, actually we can also say the vector v. Okay. In this case, the question is saying that the v is parallel to our vector, right? So this v I plus 4j minus 2k is parallel with the vector equation, which means, okay, We can also say the V is direction, or specifically direction numbers of line L. Okay. So our vector equation, the directions is based on V. So the other terms we call is direction numbers. Okay. Okay. So for these direction numbers, let's write down the from here. Okay. So let's write down the, or just let me just copy here and write here. So we have now the parametric equation of x, y, and z. Another way to describe these equations, okay, we can solve t. Okay, so the t is equal x minus x0 divided by a, and t also in the second equations divided by b, and in third equation divided by c. And since the t will be the same on each axis, we can write down this as so this is called the symmetric equations of L. And A, B, C should not be 0. Okay. If one of them 0, for example, if A is 0, we still can write down the symmetric equations, but the terms in A will be like this, and the rest will be similar with the previous, which means the line L lies in vertical plane x equal x0. Okay. Okay. Uh, Let me give you another example. So find parametric equation and symmetric equation of the line that pass through point A 2, 4, -3, and B 3, -1, 1. And the second question is, at what point this line intersect the xy plane? Okay, you can try to solve this example. First, you can find the parametric equations by looking at the point A and B and make some conclusion from that point. And then symmetric equations mean symmetric equation means this form. This x minus x0 divided by a, y minus y0 divided by b, z minus z0 divided by c. That's the symmetric equation. Okay, so first find parametric equations. Meaning for each axis, you need to find the relations and with the parameter t. Okay. Okay, now to start with, we can see the questions carefully. So first, the line passing through A and also B. Okay. If you want to imagine in the picture, you can try to draw and see we have A, B, and we have line. Okay. So what the question means is, because the question didn't give any information about the directions, right? So we just assume, and we are using the vectors A, B as our directions. Okay, so we can find AB, the factor AB, from this point minus this, and that is become our V. Okay, and later we can use either A or B as our initial point, and that way we have vector equation and then parametric equation. And from the vector v, we can also find the symmetric equations. Okay, let me write vector AB first. Okay, so AB, vector AB is 1, 3 minus 2, 1, minus 1 minus 4 is minus 5, 1 minus 3 is 4. Okay. Let AB becomes our V. So we have A, B, C. If you remember the direction numbers, A, B, and C. And take point A for -3. This will be our initial point as P0. So we can have X is 2 plus T. Or let me write, this is actually A, T. So it's become 2 plus T. And Y become 4 plus, or in this case, it's -5 T. Or maybe let me write in terms of ABC first. So we can write this as 4 minus 5t, -3 plus 4t. And this is become our parametric. Okay. So I hope these examples can help you to familiarize with the terms, okay, with the terms of parametric equation in vector, symmetric equations, okay. And the next thing is the symmetric. So symmetric equations, we will have x minus 2 divided by 1, y minus 4 divided by minus 5, and z plus 3 divided by 4. Okay, so this is A, B, C. This is x minus x0, y minus y0, z minus z0. Okay, the second question, the intersections, okay, the line will intersect the xy plane when z is equal 0, right? When z at the level 0, the line will intersect the xy plane. So we have z is equal -3 plus 4t. So when z is 0, we will have t is equal 3 over 4. And using this t, we get x is equal 11 over 4. And we get y this is 1 over 4. So line intersect xy plane at 11 over 4, 1 over 4, and 0. And that is the point for the intersection. Okay, from this example 2, sometimes we need, let me write here. Sometimes we just need a line segment, not entire line, or in this case, the L. Okay. In our case, in this calculation here, we are interpreting that L L is just a line. Let me write. L is between P0 and P, right? But sometimes we need to observe not the entire line, but only a segment. Okay. So if we put t equals 0, we get the initial point, right? 2, 4, and negative 3. And if we put the t equal 1 from this equation here, if we put t equal 1, we get 3, we get negative 1, we get this b here, 3, negative 1, and 1. So we get the p. So the line segment AB is described. So x2 plus t and the t is from 0 to 1. Or we can say the RT and from 0 to 1. And because of the relations of t from 0 to 1, we can also exchange this R or let me write in terms of so the line segment from R0 to R1 is given by vector equations RT 1 minus t R0 plus t R1. The t is from 0 to 1. Okay, what does it really mean is from these equations that you will have, before you are equating the line, right? Directly line. But for this equation, you can trace down the line. For example, before you trace down the AB, these vectors, right? What this really means, you can trace down the same vector AB, but you can trace each segment by segment. Okay. So if t equal 1 is the full line like this one, we can make some segmentations from A to some t between 0 and 1. So we can like tracing the line, okay, from these equations actually. Okay. So I hope you understand the what I mean. Okay. Okay, maybe last part for today. I will give you the planes. Okay, so this is line, and the next one is plane. Oh, by the way, I forgot to mention the terms. There are terms called skew lines. Skew lines. Okay. Skew lines means they don't intersect. They not parallel. Okay. So, for example, this A and then this B. Um, Imagine that this two is like this. So it's not intersect, it's not parallel also. Okay, so it's called the skew line. It's called the skew lines. How to prove that maybe some lines are skew? Uh, we can check and solve. Okay, we can check and solve and try the t. If they don't match, we can make sure that okay, some lines will be skew lines. Okay. Maybe later I will give you the exercise after we finish the chapter 12. But let me just go to the next sections. It's called the planes. So I will draw the illustration. I hope you can see clearly. Let me make the plane first. Well, let's say that is our plane. And to evaluate, let's make this 0. So let's say this is R0, this is R. Say this is point P, and this is P0, X0, Y0. And we have okay, let's say that is n. N is for normal. Okay, normal means um, the vector that orthogonal to the plane. Okay, and let's say this is making 90 degree to the plane. So let me write some so the plane, let me write maybe here. So the plane maybe here. So the plane is determined by point P0 in the plane and vector n that is orthogonal to the plane. Okay. Let R0 and R be the position vector of P0 and P. So R minus R0 is P0P vector. That is this light blue here. That is the R minus R0. And because n is, since n, vector n is orthogonal to every vector in the plane. So we will have the dot product of n with the vector will be 0. This is first definition. Okay, so let me explain a little bit. If you have a plane, or how we know from the definition, there is a plane there. First, we need to define. Okay, so if, for example, in the plane we have a vector that is orthogonal to every vector in the plane. Okay, so for example, in the plane it's a 2 dimensions, right? The plane 2 dimensions. It has every vector inside. So if you have n, and that n will be orthogonal to every vectors inside here. For example, in this case, we observe this R0 here and R, and we have this vector, the light blue here, the R minus R0, and that is also orthogonal to n, right? So every time we find that n is orthogonal to every vector inside the plane, we call that, okay, there is a plane there. Okay? And to find or to confirm that the n is orthogonal to the plane, we can use the dot product that is equal 0. So that is how we confirm that there is a plane. Okay, so that's the definitions in terms of vector, that we will have a plane when we have the n is orthogonal to every vector inside here. Okay, I hope that's explained. Okay. And these two vectors is just example. It can be here, it can be here, it can be here, everywhere. Okay. And this n will always orthogonal to every vector in the plane, right? Okay. And we can also write down this term in terms of this is this also. Because that is also true, right? And we can also break down the scalar equation from the n, from the orthogonal vector. So let me write a scalar equation of plane through, let's say, P0, and with a normal vector n. Let's say the n is ABC. This means ABC, and then dot the let's say through P0, and P is also XYZ. Let's write all terms here. So we can expand this, become x minus x0, y minus y0, and z minus z0. And this should be 0. And we can dot all A, B, C with the x, y, and z. So we can write down A, and then plus B, and then plus C, and it's equal 0. And this become our scalar equations of the plane. Okay, that's the scalar equation of the plane. So if you want to find an equation of the plane, you can go to this equation. The first thing is you need to know the vector n, the normal vector. Okay. So let me give you some example. So find equation of plane through 2, 4, -1 with n, the normal vector is 2, 3, 4. So if this is A, B, C, we can go directly to 2, and then x minus 2 plus 3, y minus 4 plus 4, z plus 1. And then we can solve this and find the equation of plane. That is 2x plus 3y plus 4z equal 12. This is called linear equation in xyz. This is linear equation, not linear equation as in 2 dimensions like line, but this is linear equations in x, y, z. So in the 3-dimension space. And if you want to find the intercept, if you want to find the intercept, for example, the intercept, we can set y equals z equals 0. And we obtain x is 6. And we can also obtain with other terms. And we get 4. We get also 3. And we can draw the sketches. So x is 6 maybe here. Y is 4 might be here. And z is 3 maybe here. And this is our plane. So to find the intercept, we can find through the equating with 0. 2 variables equating with 0, and we find the intercept for each axis. And this is our plane. Okay. I think that's it for today. So for the next Wednesday, we'll continue a little bit for the plane. And I think, so I think for the Wednesday, I will continue to the plane, and I will hold on the 12.6 on other session. So after 12.5 finish, we'd go directly to review chapter 10, 11, preparing your midterm on Wednesday, and on Monday also still exercising this chapter 10 and 11. And the Wednesday will be the midterm. Okay, so we will have enough time to have some exercise, having some problems to be solving. Okay, to solve some problem. And I think that's all. So if your friend asking when the midterm, it's Wednesday, 28. Okay.